pre-calculus students, or good afternoon, good evening, whatever time of the day it might be. Welcome to class today on Tuesday the 24th. I hope that your test went well yesterday. Always enjoy having you guys over, fellowshipping a little bit, and helping you with your math. Please continue to work hard. You cannot call me too much. That does not bother me, or email me. You cannot email me too much. That's my job. So please stay in contact with me if I can help you in any way. Some quick announcements like usual. First of all, there will be a quiz this weekend like usual. We have a quiz one week and a test the next week, so we just had a test. So this weekend I will be emailing you a quiz, so make sure you understand that, and we'll go over on Friday what will be on that quiz. Please communicate to me about your test. Some of you took the test on Monday. Actually, I'm making this video before Monday, so I'm not sure what really happened on Monday, but usually some of you take the test and some of you do not. So if you did not take the test on Monday, I will give you until Friday, like I always say, and I email your parents and tell them that, but I also email them and tell them my recommendation is to go home Monday and finish the test. The help that I've given you is fresh on your mind, and I just feel like with the new math we're covering throughout the week, it's going to be really difficult to stay caught up on the videos and take the test. Another compromise could be for you to take the test on Tuesday and then watch the videos Wednesday, Thursday, Friday, and Saturday. But that's all up to you and your parents. Today's math is really, really long and difficult. Please take great notes. Please pay attention. Please rewind the video if necessary, and call me if you need to, okay? That's what I'm here for. Please do that. I'm going to teach today for a very long time, maybe close to an hour. However, I am not going to give you any homework. Okay, let me repeat that. I'm not going to give you any homework. Now, you need homework. This is difficult math. You need to practice it. But you're going to practice it tomorrow on Wednesday. So tomorrow's lesson, Wednesday's lesson, will be homework only. There will not be any teaching video. Now, there'll be a homework video in which I'm helping you with your homework in case you have questions, but there will not be a teaching video. I am not perfect, but I try to be a reasonable teacher. I believe you should be able to sit and take notes for 30, 40 minutes and then also do homework. But when the math is this long and difficult, plus the homework on Wednesday you're going to do tomorrow is a really long and difficult assignment. It'll take about an hour, which is totally fair because there's no notes on Wednesday, just homework only. So when it's really like this, I try to break it up into 2 days to be reasonable with you and not to completely devastate you with the amount of time that you have to put into this class. Yet I want to push you, of course, and and make this class a challenge. We are looking today at something called sine and cosine graphs. We're going to graph sine and cosine functions today. Contain your excitement. The lesson number is 5.6, and if you're one who likes to keep track of the date, which I encourage you to do that, today is September 24th, 2013. Okay? Sine and cosine graphs, lesson 5.6. Now, first of all, you do not need to copy this in your notes. You can turn to page 497 and see the exact same thing that's on the screen in front of you. I took my digital camera, I took a picture of that page, and then I cut and pasted this out using a cool little thing right here called screen clipping. Okay, and that's something that MemoPad does for you. Okay, now the only difference is when I teach you to graph these in a couple minutes, we're not going to use radians. Radians, in my opinion, make the problem really difficult. I guess if this was a super honors class, we would leave it in radians and work with it. But we're going to convert radians to degrees. So if you'll notice in your book, do you see my pen right here, guys? In your book right here, it says pi over 2. I went ahead and made that 90. In your book, it says pi right here. I went ahead and made that 180. Okay, I didn't change them all, but you can figure accordingly. 3 pi over 2 is 270. 2 pi is 360. So we're going to graph our graphs today in degree mode, not radians, to which you're probably very thankful. It makes it a lot easier. Okay. Now notice the sine curve. This is really cool. Watch this. Are you ready? The standard, now it's going to change. We're going to graph some really hard ones in which the graphs get higher and lower and they get skinnier, and some will be really wide like that. We're going to do a bunch of different stuff, okay? But the standard sine and cosine graphs go up to 1. See 1 right here? See that 1? They go as high as 1, and they go as low as -1. And they just, it's almost like a picture of sound traveling through the air. If you've ever seen that, it's a graph. It's up and down, up and down. And it doesn't stop there. It continues on and on. We just don't want to have to take the time to draw it over and over and over a million times. Now, notice that cosine is really not identical, but very close to identical to the sine curve. And by the way, I have labeled these. This is y equals sine x, and this is y equals cosine x. Or did they use s? I think they used the letter s. But anyways, notice they're pretty much the same, only instead of, in fact, they are the same, except that instead of the graph crossing the y-axis at 0 like it does here, down here it crosses the y-axis at 1. Okay? Other than that, the intervals are still the same. It still goes as high as 1 and low as -1. It still goes up and down, up and down, up and down. Okay? So I wanted you to see this right off the bat, because whenever you start graphing, remember last year, those that had me as a teacher last year, when we were graphing quadratic equations, the first thing I did is I said, hey, they're always going to look like a parabola. And we talked about it. Some will be skinny, some will be wide, some will face up, some will face downward, etc., etc. Whenever I'm graphing, teaching you to graph something new, I want to give you a picture of what it's going to look like. Now, this is just a general picture, but now you understand what you're getting out. So if you graph the sine function and you're getting something like this, you can rest assured you're making a mistake, okay? I guess that wasn't too funny, but it needs to look something like this, okay? Similar. Now, I want to show you something else. Let's talk about the period of this graph. Now, I cannot stress to you how unfathomably important this next comment is, so I hope you will listen to me. The period of the graph is how long or how many degrees it is before the graph starts to repeat itself again. The period of the graph is how many degrees or how long the graph is before it starts to repeat itself. Let me help you, okay? Here's the top part of the graph, and here's the top part of the graph. So from here to here, it's not started repeating itself. But as soon as it starts to go back down again, then it's starting to repeat itself, because here it went down, up, and as soon as it starts to go down, it's repeating itself again. So the period of the graph would run from here to here. Or, Mr. Earhart, why did you pick that point? No problem. No problem. Let's pick this point here. On the x-axis, going upward. Where's the next point you see that's on the x-axis going upward? Not this one. This is on the x-axis going downward. Here it is, right here. So you could also say the period ran from here to here. That would be fine. I have no problem with that. Or here's a low point, and here's the next low point. So you could say the period ran from here to here. Are you seeing this okay? Or you could say, if you wanted to, the period ran from here the graph is crossing the x-axis going downward. Here it's crossing the x-axis going downward. So the period would run from here to here. Now, why am I showing you this, and why is it so important? Well, thank you for asking those wonderful questions that you probably really didn't ask. You want to know the degrees. Again, let's compare it from upward to upward. This here would be -270. So how many degrees passed from here to here? Now watch, please. Watch this. Well, we know from here over to here, we know that from here to here is 90 degrees. And we know from here to here is 270 degrees. So the whole period going across before it started to repeat itself, the period was 360 degrees. Now, you say, well, Mr. Earhart, what if you chose 2 other points? Hey guys, doesn't matter. Doesn't matter. Let's say we picked a point here on the x-axis going down, and a point on the x-axis going down. Fine. So the period runs from here to here. No problem. Well, this is negative 180 degrees. This is positive 180. So from here to here, we know we have 180 degrees. From here to here, we have 180. So again, the period is 360. The period will not change because you picked different points. Okay, that does not matter. The period only changes from graph to graph. We're going to do some graphs in which the period, remember I told you how these graphs will shrink or get wider, but every graph could possibly have a different period. But no matter what 2 points you pick, this graph here will have a period of 360. You could also pick high point to high point, low point to low point. So in a standard sine graph, the period is 360 degrees. In a standard cosine graph, the period is 360 degrees. Now again, the period is how many degrees exist, or how many degrees are in between the graph before it starts to repeat itself again. That's what period is. You'll get more used to it as we do it, okay? Just pay attention, take good notes, and listen. Now, we need to talk about these models. So please write down your notes. Y equals A sine bx minus c plus d. Y equals A cosine bx minus c plus d. Now just determine in your minds now. If you got to take a break after 30 minutes and get a snack so you can stay awake or stand up and stretch or get a drink, that's fine. It's going to be a long video today, about an hour, but there's no homework. So just understand that and be ready for it, and you know, and really listen well. Now, I want you to write these two models down. Now, I need to talk to you about what A, B, C, and D represent. And I did not do that for both of these models because both models are the same. Okay, it doesn't matter. So it doesn't matter if you're dealing with a sine function or a cosine function. A, B, C, and D all refer to the same thing. So let's take some notes. Whenever you see a sine function or a cosine that looks like this, the number out in front of the sign, we call that A, is the amplitude or height of the curve, of the graph. And I will explain that later. You need to know now that this number here is the amplitude or height of the entire graph. Moving on. Hopefully. Maybe not. Okay. B affects the period. Now I told you the standard period of a sine cosine graph is 360 degrees. But this number right here that's in front of your x, your B, it'll be a number in some of the problems, affects the period. Okay? And we're going to learn about that later. Right now you just need to know that B affects the period. C affects the horizontal shift. Again, I will explain all of this later. Right now you just need to take notes on what each letter stands for. C will affect the horizontal shift, and D will affect the vertical shift. It affects the vertical shift. Okay? All right. Now I know you're pausing the video a lot, and I know you're writing stuff down, and that's fine. I go fast on purpose because some are faster writers and they grasp concepts faster than others, and others don't. And there's nothing right or wrong about that. That's just how God has created all of us different, and that's fine. So, you know, if you got to pause the video a lot, no problem. Now, I've showed you what each of these letters / numbers will stand for. By the way, what do you mean by numbers, Mr. Hart? Well, I'm going to show you real quick. Just sit tight. Like this problem right here. Look at this. Don't write this down, but look. This would be your A, this would be your B, this would be your C, and this would be your D. So later on when we start graphing these, you will see that these letters are really going to have numbers, and then we're going to go from there. Okay, now we need to write some steps down. As you know, steps are very important. Steps for graphing sine and cosine functions. There are 29. Just kidding. There are 7. Convert the radians over to degrees. Listen, guys, it makes the problem 1,000,000 times easier. Convert the radians over to degrees. Step 2, find the vertical shift and put dotted lines on the graph. I will teach you how to do that later. Number 3, find the amplitude and put dotted lines on the graph. I will teach you how to do that later. Number 4, find the horizontal shift and write down this number. Write this number down, okay? Write it off to the side somewhere. Number 5, find the period. I'm going to teach you how to do that. And divide it by 4. Write down these partial ordered pairs. I will explain that later if you'll just trust me. Number 6, substitute in two values into your function, into your equation, in order to get out two y values. I will teach you how to do this later. Number 7, sketch the graph. Sketch the graph. Okay? All right. Now, let's go ahead and try our first problem here, and I will walk you through these steps very slowly. And let me see how many problems. I like to give you guys closure. We have 1, 2, 3, 4, 5. And I told you it's going to be a lot of notes today, but no homework. So we have 5 of these to do, and they will take a while. Let's go ahead and try our first problem here. Y equals sine x plus 3. Please write that in your notes. Now, I put the models up here so you can see the models so we know what A, B, C, and D are, etc. Now, step 1 says to convert any radians that you see over to degrees. Now, I do not see any radians. Let me say that again. I do not see any radians. Well, Mr. Earhart, there's no degree symbol with that 3, so 3 must be radians. Hold on. Don't miss this. There's a lot of side notes you're going to have to take in this lesson, so write down what you need to, okay? If there are any radians in the problem, they will always be inside this parentheses. Always. Because you're taking the sine or cosine of the radians or of the degrees. Okay, so any number you see out front here, like a 6 or any number at the end here, they're not going to be radians. Radians are going to be inside the parentheses. Hope you got that. So there are no radians. You know how when we graph these, I start off with easy ones where you don't need to use all the steps, and then we build up to more and more difficult ones, like the last one that we're going to do today. This one here, we're going to use all the steps. It's going to take a while, okay? So there's no radians to convert over 2 degrees. Fine, no problem. Moving on to step 2. Find the vertical shift and put dotted lines. Now, the vertical shift, if you'll look in your notes, it's always this number right here, D. So we see that we have a vertical shift of positive 3. Also notice D is outside the parentheses. D will never be inside the parentheses. So would you please watch? If there would have been parentheses like this around x plus 3 and there was no number out here, then your vertical shift would have been 0. If there's no number, go ahead and put plus 0. But your vertical shift will always be outside the parentheses, will never be inside. Well, I don't see any parentheses, Mr. Earhart. Well, if you want to go like this, feel free to. The point is this. This vertical shift will never be inside a parentheses at all. So your vertical shift is D. Here's D right here, 3. Here's your D, 3. So your vertical shift is 2. So we're going to go ahead and, like I just said to do, we're going to go ahead and in your notes somewhere, go ahead and draw a coordinate plane. Draw it pretty wide, like this. And I'm going to draw mine decently high. And I'm going to use red. Red will stand out a little bit. You do whatever you would like to do. And our vertical shift is positive 3. So I'm going to put a dotted line. If you'll look at your steps, find the vertical shift and put dotted lines. So what I'm going to do is I'm going to go up 3. And actually I'm going to spread those out a little more. I would encourage you to do the same. Make them a little wider. There you go. And put a dotted line going through 3. Now that's easy. Everyone can do that, okay? I'm not being smart with you, but that's pretty easy. Whatever that last number is. Well, I don't see why I'm doing it. Trust me, you'll see in the end, okay? You will see in the end. So step 2 is done. Step 1, convert to degrees. There is no radians to convert. Step 2, find the vertical shift and draw a dotted line. Step 3, if you'll look in your notes, find the amplitude and put dotted lines. Okay, now if you'll look in your notes, what I said is A is the amplitude or height, okay? A. Well, my A here is a 1. There's no number in front of sine, so it's a 1. So what that means is this. When you put this dotted line, men, in the middle like that, the amplitude means you go up from this dotted line here. You go up 1. Put a dotted line. And then you go down 1 from that middle dotted line that you drew from step 2. Cool beans, as my wife says. There we go. So we're doing pretty good. Now, Mr. Earhart, what if this number would have been a 2? then no problem. From your middle dotted line here, you would have gone up 1, 2, put a dotted line there, and then you would have gone, here's your middle dotted line, you would have gone down 2 and put a line there. So either way, it's done the exact same way, no tricks. Now let me pause for a second and tell you why we've done this, okay? What you've done, this is really cool, you're going to love this, and I'm being serious. What you've done is you've made a boundary, and now your entire graph is going to be like this. Isn't that cool? So what you just did is you found a boundary, and now you know how high the graph's going to go, and now you know how low it's going to go, and you know this positive 3, 1, 2, 3, you know this positive 3 dotted line right here, you know that splits it right in half, that's right in the middle, and you know how wide it goes. That's really helpful when you draw your graph later, guys. I promise it is. It really is. Okay, so steps 1, 2, and 3 are done. Now, step 4 says, find the horizontal shift and write this number down. Now, you're going to have to take some side notes. So are you ready to take some side notes? I have to teach you how to do step 4. Whatever you're taking the sine or cosine of, now look up here, that would be this, whatever's in the parentheses, okay? Well, again, Mr. Earhart, there's no parentheses. I know. So in this case, it's just x. Okay, if there's no parentheses, it's just the x. Whatever you're taking the sine of, in this case, or the cosine, in this case, we're taking the sine of x. You always take that, set it equal to 0, and solve. That's really, really cool. So whatever you're taking the sine or cosine of, in this case it's x, you take it and you set it equal to 0 and you solve. So you take your x right here, you set it equal to 0 and you solve. Well, there's nothing to solve, okay? Now when we get into a harder problem like this one over here, right here, when we have 2x minus pi, then we'll have to take 2x. Of course, we'll convert pi over to 180. So 2x minus 180 equals 0. Then we'll add 180 to both sides. Then we'll divide by 2, and we'll get 90. So as the problems get harder, there's more work to do, okay? But as of now, in this problem, all that we have is an x right here. Right here. So we take that and we set it equal to 0 and we solve. And we did. There's nothing else to do. Now what step 3 says is write that number, or step 4 says is write that number down. So somewhere make note that the horizontal shift is 0. In other words, it's not going to go anywhere. We're going to use that number later though. I'm going to refer to this as the number from step 4. So the number from step 4 is 0. Got it? The number from step 4 is 0. Now we're moving on to step 5. Now step 5 is actually 2 parts. It really is. Because step 5 says to find the period. So we got to do that. And then divide it by 4. Now, and we have to do that. Now if you'll look at your notes, if you'll look at the letter B in your notes, I told you the letter B affects your period. Okay? The letter B affects your period. So I'm going to give you some side notes. Please take really good notes. How do you find the period? Well, I'm glad you asked. You always take 360 degrees, that will never change, never, and you divide it by whatever B is. So I'm going to put the letter B. It's that easy. Again, can I go ahead and give you a little encouragement? When you take your quiz this Friday or this Saturday over the weekend, I'm going to let it be. I don't mind doing this at all. This is not watering down your education, because when you take the test, I'm not going to allow this. But when you take your quiz this Saturday, I'm going to allow you to have open notes on these 7 steps. You'll be allowed to have these 7 steps written down, plus you'll be allowed to have, well, sorry guys. I guess I could just go real quick here. I'm going to let you have all of this right here written down. But you will not be allowed to have examples in front of you, like how to, actual graphing a problem. But you will be allowed to have those written down to help you. So all of these side notes that you're taking, like with your steps, like right here besides step 2, or besides step 4 here, you should write down set equal to 0, whatever you're taking the sine of. Step 5, you should write down take 360 and divide it by B. Write that down. You can have all that on your quiz over the weekend. I don't mind that. On the test, you won't be allowed to. Okay, so how do you find the period? You always take 360 and divide it by B. Now, B is this number in front of x. Notice there's no number in front of x, so we simply say 1. So 360 divided by 1 is 360. Let me cross off this B. 360 divided by 1 is 360. So the period for this graph is 360 degrees. There you go. You just found the period. Cool. Now step 5 also says take the period and divide it by 4. Okay? So we're going to take the period, which is 360 degrees, and we're going to divide it by 4. And this will give us 90. Then it says to do this. It says write down partial ordered pairs. Now let me help you do that. This is where it gets a little confusing. Okay? So let's very quickly review. Step 1, I converted radians over to degrees. There were none. Step 2, I found the vertical shift by this number right here. And I put the dotted line at 3. Step number 3, I found the amplitude. I went up 1 and down 1 because the number right here in front of sine is 1. And so I put dotted lines there. Step 4, I found the horizontal shift by taking this right here and setting it equal to 0 and solving. And then step 5, I found the period by taking b and dividing it into 360 degrees. And then I took the period and divided it by 4. Now, here's what I need you to do. Please pay really close attention. I need to write down, we're going to write down 5 ordered pairs. 1, or partial ordered pairs. 2, 3, 4, and 5. Now, let's refer back to the number in step 4. The number in step 4. When you found the horizontal shift, you got out 0, correct? Okay, that goes right in the middle, right here. Now, the reason you took 360 and divided it by 4 is this number here, 90 degrees. 90 is what you're going to add and subtract. So we're at 0. So my next x value would be 90. My next x value would be 180. Now I go backwards. 0 minus 90 would be negative 90 degrees. And then subtract another 90, and it would be 180 degrees. So now you see in step 5 why it says write down partial ordered pairs. Do you see how they're partial? They're not complete, guys. Okay? They're not complete. We just have the x values for each one. So let's review for the 100th time. Sorry if I'm boring you. You take 360 and divide it by whatever's in front of the x. In this case, it's 1. 360 divided by 1 is 360, so your period is 360. You then take your period and divide it by 4. By the way, I'll tell you why. I'll show you why real quick, since I'm sure you're dying to know why. From high point to high point, we have 4 sections. Here to here, I call that a section. From here to here, I call that a section. From here to here, I call that a section. And from here to here, I call that a section. How many sections did we have? 1, 2, 3, 4. And so this is a whole period from here to here. So you're dividing your whole period up into 4 critical values. Now you might have understood that. You might not have. If you didn't, don't worry about it. I'm just trying to help those who have a higher level of learning in this class to see why we're doing what we're doing. Now, step 6 says substitute 2 values in order to get out y values. So you simply come up here, and I don't care what you put in. You can use any 2 values at all. I'm going to put 0 in for x, and then I'm going to put 90 in. Now I'd like to give you a little caution here. Make sure your grapher or your calculator is in degree mode because we are using degrees. So please make sure that your grapher is in degree mode. Once you've made sure your grapher is in degree mode, I'm going to put 0 in for sine. So with your calculator, take sine of 0, hit enter, you should get 0, and then plus 3, and you should get 3. Let me go over that again. Put 0 in for x, so take sine of 0, hit enter, and then plus 3, enter, and you should get a 3. So there you go. You put a input, output. We learned this in Algebra 2. You put a 0 in for x, you got out 3 for your y. Now put 90 in. If you type in sine of 90, enter, you will get 1, and then hit plus 3, and you will get 4. So let's quickly plot those points. I know here I'm at 0 degrees, and I went up 3, 0, 3. So 0, 3 is right here, and then 94. So I'm going to go over about right here and put 90 degrees. So it looks like I'm going to divide my x-axis up into sets of 90. That'll change depending on how big your period is and where the horizontal shift is and stuff like that. But notice I'm going over 90 because remember when I took 360 and divided by 4 it was 90. So here's one ordered pair, 0, 3. Here's the next ordered pair, 94. Now Mr. Earhart, why didn't you do that for all 5? Guys, there's no need. Look, once you get the model, look, once you know the graph is going like this and it's hitting here, remember, we know then it goes down next. So at 180 right here, it has to be in the middle. It has to be. At 270, it has to be down here. It has to be. Because we know what it looks like. Once you get two values, it's pretty easy. And then it hits here, and it curves back up. Just put an arrow, okay? Now, we know we're here, so I go down to 90. That's my next critical value. I put a point here. I know it's got to curve back up. My next critical value is negative 180, so I put a point here. My next critical value is 270, so I can put a point here. And now we got a really nice picture of this graph. They don't take sharp turns. They take smooth, rounded curves like this. And there we go. You did it. All right. You just graphed your first sine cosine function. All right. A lot of work. And I told you it's going to be an amazingly long video today, but you will not have any homework. Okay. And the good news is tomorrow I've only given you about 200 of these to graph. So that's the good news. Okay. Let's give another problem a shot. All right, go ahead and write this video down, or this problem while I'm getting a little drink of water. Okay, y equals cosine 2x, or y equals 2 cosine x, excuse me. All right, here we go. Let's go a little faster now. Step 1, change everything over to degrees. Well, I taught you in the last problem, if there's any radians that need to be converted to degrees, they'll be right here in a parentheses. And I'm not saying anything like that, just an x, so we're good. Step 2, find the vertical shift and put dotted lines. Now, D is your vertical shift. Notice there is no vertical shift, so you really could put plus 0 if you need to. So the vertical shift is at 0. There isn't one, in other words. So step 2 says find the vertical shift and put a dotted line. So I'm going to go ahead and draw my coordinate plane. Well, that's really good. Here we go. And there we go. Now, since I need to fix that real quick. Since your vertical shift is 0, students, then you're going to have to put a dotted line right on the x-axis. Make sure you can see it. You do it however you want to, but there's where your dotted line would be. So step 2, find the horizontal shift. That's your D, or your vertical shift. Sorry, your vertical shift. I hope I've not been saying horizontal shift. Take your vertical shift, which is D, and put a dotted line there. Step 3 says find the amplitude and put dotted lines. Now the amplitude is your A, right here, your A. Your A, right here, okay? So in this case, your amplitude is a 2. So that means from the middle dotted line, you're going to go up 2, and from the middle dotted line, you're going to go down 2. See how this one's going to be, this graph here will be higher. It'll have more height than the other one did, okay? All of these graphs will come in different sizes. So there we go. I got it. I got this, all right? There we go. So I've got a really nice boundary now that will help me get my graph in there pretty nicely, okay? All right, step 4, find the horizontal shift and write this number down. Now remember, the horizontal shift, we take whatever we're taking the cosine or sine of, and we set it equal to 0. It's always going to be this parentheses. If there's no parentheses, then it's just this right here. So I'm going to take x, set it equal to 0, and solve. Well, there's nothing to solve. X equals 0. So step number 4 is done. Write that number down. Step 4 says find the horizontal shift and write the number down. So your number from step 4 is 0. Write that down. Okay, step 5, find the period and divide it by 4. Now, the number that's with the x, your B. Your B, in this case, it's a 1. There's a 1 in front of the x. This affects the period. So when step 5 says find the period, you always take 360, that doesn't change, and you divide it by B. In this case, B is 1, so your period is 360 degrees. So write that down somewhere in this problem. You just found the period is 360. I erase it because I don't have a lot of room to work here. On your paper, you should. Then step 5 says take the period and divide it by 4. So we divide it by 4, and we get 90 again. So that's going to help us. That's going to be the number that we're going to add and subtract here in just a second, okay? All right, so step 5, we found the period. We took the period. We divided it by 4. Write down these partial ordered pairs. Now, what I taught you to do is this. Remember, I said to you, look at your number from step 4. In this case, it was a 0, okay? And then we're going to write down 2 more ordered pairs to the right and 2 more ordered pairs to the left, or partial ordered pairs. Now we're at 0. I know that I'm going to add and subtract 90 because when I took my period and divided it by 4, I got 90. So 0, I add 90 again, then I go the other way and I subtract 90, and I subtract 90 again. So very good. I'm doing pretty well on these guys. They're going to get harder, but still. Now, step 5 says substitute in 2 values and get out two y values. It doesn't matter which 2 values you use. I'm going to go ahead and use 0 and 90 again. So where x is right here, I'm going to substitute in a 0. So with your calculator, go ahead and take the cosine of 0, and you make sure you're in degrees, and when you do, you'll get out 1. So now you have 2 times the cosine of 1. There's a 2 right here. 2 times. Notice that the 2 is right next to the cosine. They're multiplying. So 2 times the cosine of 1. Well, the cosine of 1 is, 2 times the cosine of 90. I apologize. 2 times the cosine of 90. Well, the cosine of 90 is 1, so 2 times 1. And I'm just having a really bad day today. It's the cosine of 0, isn't it? That's okay. You're used to me making many mistakes, and I apologize. 2 times the cosine of 0. 2 times the cosine of 0. The cosine of 0 is 1. 2 times 1 is 2. Apologize again for my verbal errors. Now, next I'm going to put 90 in. 90. So now with your calculator, take the cosine of 90. You have 2 times the cosine of 90. 2 times the cosine of 90. The cosine of 90 is 0, so 2 times 0. 2 times 0 is 0. So my one ordered pair is 0, 2. That's way up here. My other ordered pair is 90, 0. So I go over 90, and I'm at 0. Now your other critical values, of course, would be 180. I'm adding 90. You're always adding 90. Not always, but in this case, we're adding 90 because remember, guys, I took my period and divided it by what? 4. In step 5, I did that. That's a very important piece of information there. You've got to get that right, or all of these numbers will be wrong down here. And I go 90 the other way. 90 minus 90 is 0, and then minus 90 again would be, put a 0 right here, and then I would have a 90, or a negative 90, negative 180. Negative 270. How many mystery heart do you want us to put up here? I don't care. Just be thorough and do a good job. So I kept adding and subtracting 90. Now my one ordered pair was 0, 2. My other ordered pair was 90, 0. So I know my graph's going to hit here and come down to here. So I know my next critical value will be down here. My next critical value will be right here in the middle. So you hit here. It's not a sharp turn. It's a smooth, rounded turn. And then it comes up and it continues onward. Here, I know that at critical value 0, I was at a high point, so 90 is going to be right here in the middle. 180 will be down here. Then it goes back up. 270 will be here in the middle. And then 360 will be here. So, makes a nice rounded turn right here. Hits that point right there. Hits that point there. There. And there. We did another one. Not too bad. Pretty good. Okay, little water break there, and now we're moving on. Let's try another one. You know what? These are really getting repetitive. Hold on, though. No, this is a good one here. We need this. Then we have 2 more after this. Okay, go ahead and write this in your notes, please. Go ahead and write this in your notes. And let's graph this. Let's fly. Here we go. Step 1 says convert radians over to degrees. Now remember, if there's any radians to convert, you'll see it right here, and it will always be the C. I'll just go ahead and tell you right now, C will be the radians you're going to have to convert, and there is not a C, so we're okay. Step 2, find the vertical shift and put dotted lines. Well, the vertical shift, remember I'm taking the sine of 4x, okay? If you want to put parentheses around it, feel free to. The vertical shift is always this number right here, D, and in this case you're welcome to put plus 0 if you want to. So the vertical shift is at 0. So very quickly, I've got to put a dotted line at 0. There we go. And so I'm going to change colors, and here's my dotted line at 0. There you go. You found your vertical shift. and there isn't one. It's right at 0. Okay, step 3, find the amplitude and put dotted lines. Now the amplitude is always this number here in front of your sine or cosine. So it's a 2, so I know I'm going to go up 2 from the middle dotted line and down 2 from the middle dotted line. So put a dotted line there. Step 3 says to go ahead and put dotted lines. I am going a little faster now, guys, getting a little sloppier, but I'm trying to hurry for your sake more than anything else so we can get this video done. Now remember, what you've done is you have yourself a really nice boundary. You have a really nice boundary set now that you know the graph's going to take place in here, and that's a real big help, okay? So we've done steps 1, 2, and 3. Step 4 says find the horizontal shift. Now remember, we always take whatever we're taking the sine or cosine of. In this case, we're taking the sine of 4x. So it'll always be this parentheses. And we set it equal to 0 and we solve. So 4x equals 0, divide both sides by 4, and x equals 0. So there, we did step 4. Write that down. The number for step 4 is 0. We're going to come back to that later. Okay? All right, step 5, find the period. Now remember, you always take 360 to find the period and divide it by b. b is the number next to x. In this case, it's 4. So I have 360 divided by 4. So my period, this is going to be a weird one, my period is 90. Now in the other two graphs, your period was 360. In this problem, the period's 90. Let's go over that again. How do you always find the period? You always take 360 and divide it by whatever number is next to the x. In this case, it was a 4. So 360 divided by 4 is 90. So step 5 says find the period. We did that, guys. It's 90. Now step 5 says take the period and divide it by 4. So I'm going to take 90 and I'm going to divide it by 4. And if I do that correctly, I'm going to get a decimal, which is okay. I'm going to get 22.5. Now that's the number we're going to have to add and subtract over and over and over. All right, so let's review. 360 divided by 4, because there's a 4 right here, gave me 90, so my period is 90. Then take the 90 and divide it by 4, I get 22.5. Okay, and now step 5 says write down your partial ordered pairs. Remember what to do? Let's see if you remember what to do. You take your number from step 4, in this case it was 0, and you put it right here in the middle ordered pair. And then we want a couple more ordered pairs going this way. And we want, let me get the eraser out here, you should have 22.5 written down somewhere. Did not want to do that. There we go, and there we go. And then we go a couple ordered pairs this way. Now, the number from step 4 was 0. That's my horizontal shift. That tells me where to go horizontally. In this case, it'll be a 0. And then I took the period and divided it by 4, so I'm going to add 22.5 over and over. All right? So I add and subtract. So I take 0, add 22.5, add 22.5. Now I'm going to subtract it. Subtract 22.5, subtract 22.5. And there we go. Now I'm going to go ahead and put these values down here on my x-axis. So I know I've got one critical value of 0. I've got another critical value of 22.5, another critical value of 45 degrees. We're going to keep going. I've got another critical value of 67.5 degrees. I think that's right. Yeah. And now we take 0 and we go the other direction. We subtract 22.5, so negative 22.5. And then subtract 22.5 again, negative 45 degrees. And then subtract 22.5 again, we get negative 67.5. That's sufficient. That really is good enough, guys. Okay? All right. So there we go. Now, the next step in step 6 says substitute in two values and get out two y values. I'm just going to use 0 and 22.5. Are you ready? With my calculator, I'm going to take sine of, well, 4 times 0. Sine of 4 times 0. Now, let me help you do this, okay? Don't worry about this 2 right now. We'll get to that later, okay? Actually, you can type the whole thing in at once. Let's just do the whole thing at once. That'll be a lot easier. So with your calculator, I want you to hit the number 2. So the number 2 pops up, so hit 2. Then hit sine, and when you hit sine, this should pop up right here, sine with the parentheses. And then I want you to type in 4 times 0. And then hit enter. Close your parentheses. So 4 times 0, close your parentheses, and you will get out 0 for the whole thing. If you did it correctly, you'll get out a 0. All right? Now, did not want to do that. We'll just let that go. All right. Now we're going to put in 22.5. So I'd like you to type into your calculator 2 for this number here. So go ahead and hit 2. Then hit sine. When you hit sine, this will pop up, sine with parentheses, and type in 4 times 22.5. All right, and what you should get is, I just messed mine up, 2 sine of 2 times 22, or 4 times 22.5 will give you the number 2. Will give you out 2. So we know one ordered pair is 0, 0. We know another ordered pair is, actually you got out 2 right here, I apologize, so 2. Another ordered pair would be 22.5, 2. So here's your critical values going across. So I know I went from here up, so my next critical value will be here in the middle. My next critical value will be down here. Let's go backwards now. I went here, 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 here. So my next critical value will be down here. My next critical value will be here. And my next one will be up here. So we are really ready to move now. If you are good at doing dot to dot, and my 7-year-old is, so I'm assuming you are too, that's it. We did it. All right. Going a lot faster now. We have 2 left. And now we're getting into the granddaddy. So this will be really good for you guys. All right, let's go. Step 1 says convert any degree, any radians that you see into degrees. I already told you, any radians that you're going to see is going to be this letter C right here. I'm telling you right now. Okay. So see this pi right here? Remember how to convert radians to degrees? Do you remember, guys? You always take the radians, whatever it is, and you always multiply it by 180 over pi. Do you remember that? If not, you need to. Anytime you're converting radians to degrees, you use 180 over pi. If you're converting degrees to radians, you use pi over 180. So you need to memorize that and know that. So I'm going to convert pi, which is radians, over to degrees. So I take pi times 180. Your pi's cancel. And 1 times 180 is 180 over 1. So instead of having pi right here, I'm going to go ahead and take the liberty to cross off pi, and I'm going to use 180 degrees. And I cannot tell you how much easier you just made that problem. It really does make a difference, trust me. So step 1 is done. We converted any radians that we saw over to degrees. Now step 2, find the vertical shift and put a dotted line. Now the vertical shift is D. And in this case, I don't see any D out here, so I'm going to go ahead and put plus 0. So my vertical shift is 0. So let's go ahead and draw our coordinate plane here kind of quickly. Trying to save some time here. There we go. And put a dotted line at 0. So there we go. So step 2 is now complete. Step 2 was find the vertical shift and put a dotted line there. And there was no vertical shift at 0, so it did not go up or down. Next it says find the amplitude and put dotted lines. Now the amplitude is always this number here in front of your sine or cosine. It's a 4. So we're going to have to go 1, 2, 3, 4. Put a dotted line. All right. And then we go down 4 from this middle dotted line. 1, 2, 3, 4. So we're going to have a really tall graph this time. Okay. And by the way, this is our next to last problem. So hang in there. There we go. So now we've got a really nice boundary that we can put our curve in. Okay. All right. So step 3 is done. Step 4, find the horizontal shift. And write this number down. Oh, we got some work to do. Remember the horizontal shift is you always take whatever's inside the parentheses. Remember? And you set it equal to 0. Cool, we got some work to do. Finally, something fun here. So add 180 to both sides and divide by 2, and x equals 90. Now write that number down. Do you see what I did? That tells you the graph has been shifted 90 degrees. Doesn't change any of the steps. Okay, I'm just trying to explain to you what we're doing here. So we took what's inside the parentheses. We set it equal to 0, 2x minus 180. Can you imagine if that would have been pi, and then trying to deal with fractions, pi divided by 2? It really is difficult, okay? So we took what's inside the parentheses. We set it equal to 0, and we solved. And so, hold on one second. So now we know the number that you write down for step 4 is 90. So go ahead in your notes, write down 90 for step 4. Now let's take a look at step 5. Find the period. Okay, stop right there. The period is always 360 divided by b. B in this case is 2. Here's b right here, the number 2. So 360 divided by 2 is 180. So the period for this problem is 180. Got it? The period is 180. So step 5 says find the period. We did it. The period is 180. And then step 5 says to take the period and divide it by 4. So now I'm going to take the period, which is 180, and divide it by 4, and I will get 45 45 degrees. Now that's the number you're going to add and subtract over and over on your x-axis and also in your ordered pairs. So the period was 360 divided by 2, that's 180. So the period is 180. Then I took the period right here, the period, and divided it by 4, and I got 45 degrees. You should write that in your notes. I'm running out of room, so I always erase all this. Now, next it says write down these partial ordered pairs. So I've got an ordered pair right here in the middle. Now, what was your number from step 4? Remember, guys? Your number from step 4, in this case, was 90. So you put a 90 right here. Got it? You put a 90. And now we're going to add or subtract. What do I add or subtract? The period, when you divided it by 4, that number is what you add or subtract. So the period was 180. You divide it by 4, you got 45. So we're going to add and subtract 45. So 90 plus 45 would not be 45. 90 plus 45 is 135. Plus 45 would be 180. 90 minus 45 would be 45, and 45 minus 45 would be 0. So that gives you an idea. I know we don't fill in all these ordered pairs, but it gives you an idea of what you're looking at here. So we know we're going to be at 90 and 45 and 0, so I can go ahead and put a 0 here, and then 45 degrees. See this, 0, 45. Then here's my 90. And then here's 135. I'm kind of running out of room for my 180. I don't care about that. It's really not a big deal, guys, as long as all of these x values right here, you're adding and subtracting 45. So here's a 0, then you subtract 45, so negative 45, subtract 45, that's negative 90, subtract 45, negative 135, subtract 45, negative 180, and I guess we could squeeze in a 180 over here. It really doesn't matter. Now, step 6 says substitute two x values in and get out your y values. I'm going to use 90, and I'm going to use 135. Got it? Okay. Now, what I would do if I were you is I would type into your calculator this whole thing, only where x is I would put 90. So here's what I would type. I would type negative 4, go ahead and hit negative 4, and then with your calculator, by the way, it's the negative, not the minus, the bottom white negative on a grapher. So negative 4, and then hit cosine. So negative 4, hit cosine, and when you do, up will pop this, and then type in 2 times, so 2 times, and then of course we're putting 90 in, so 2 times 90, so 2 times 90, and then put minus 180. 2 times 90 minus 180, and then close your parentheses and hit enter, and you will get out negative 4 if you did it correctly, negative 4. All right. Now we're going to do the exact same thing, only instead of putting 90 in for x, we're going to put 135 degrees in. So now with your calculator, hit negative 4, and then hit cosine, and then hit 2 times 135 minus 180. So what we did is where the x is right here, we put 135, and then hit enter. So I'm going to do that real quick with my calculator, so thanks for your patience. 135 minus 180. And I'm getting out 0 for that. Hopefully I did that correctly. 0. Okay? So now, so we're ready to go. We know at one point is 90, negative 4. So here's 90. See 90? 90, negative 4. So there's 1 point. And then I'll go ahead and use a different color so it stands out a little better. So 90, negative 4. And then my next ordered pair is 135, 0. So now here's your critical value. So your next critical value would be up here. Now let's go backwards. Your next critical value would be here. And then 0 is a critical value. So up here, 45 is a critical value, negative 9 is a critical value, 135 is, and negative 180. So we have us a beautiful sketch here. I know I'm trying to go fast. Hopefully you'll be a little neater than this. There we go. There's a nice graph. You did a really difficult one, and hopefully you're getting this. Okay, I'm going to grab a drink of water. Drink of water. And let's continue on. Last problem. On this last problem, we're going to do it 2 different ways. And by the way, I've kept this video less than an hour, so I've really done pretty good, I believe, guys, but time-wise. But we're going to do this with the way I taught you. Then we're going to real quick use a graphing calculator. So for those that don't have one, you don't have to follow along. Those that do, I'd really encourage you to watch how to do this with the graphing calculator. Plus, it can help you on a test or a quiz. Check your answers and make sure you're doing it well. Now, let's go ahead and graph this. We're going to go really fast. Step 1, change everything over to degrees. Well, pi over 2 is radians. So remember, you multiply it by 180 over pi. Your pi's would cancel. 2 goes into 180 90 times. So 90 degrees. So we just converted our radians over to degrees. So instead of having pi over 2 right here, I'm going to have 90 degrees. Step 2 says find the vertical shift and put a dotted line. Well, my vertical shift is this number out here, so my vertical shift is positive 1. So I'm going to go, and actually I might need, I think I'm going to need to slide that up a little bit, I believe. There we go. All right. So my vertical shift is positive 1, so I'm going to go up positive 1, put a dotted line there. That's easy enough, guys. Vertical shift is positive 1. Put a dotted line there. Okay, step 3 says find the amplitude and put dotted lines. The amplitude is always this number right here. In this case, it's a 3. So from your dotted line, you go up 3. Put a dotted line there. And then from your middle dotted line, you go down 3. 1, 2, 3. Be a negative 2. Right here. 1, 2, 3. Went down 3. So there's your, now you got your nice boundaries for your curve you can put in here. Okay? All right. So there we go. So steps 1, 2, and 3 are done. Step 4 says find the horizontal shift. Now I've taught you what to do. You take what's inside the parentheses, 2x plus 90, and you set it equal to 0, and you solve. So 2x would equal negative 90, and then divide by 2, and x equals negative 45. So write that down for step 4. So for step 4, you found the horizontal shift, negative 45 degrees. You took what's inside the parentheses, and you set it equal to 0, and you solved. So the number you're going to write down for step 4 is negative 45 degrees. So please write that down. Now, step 5 says find the period. So we always take 360 and divide it by b. In this case, b is 2. And for the period, we get 180. Got it? So if the period, we just found the period of this graph is 180. I'm going to write that right up here. Period equals 180. And now you always take the period and divide it by 4. We're still on step 5. So the period divided by 4 would be 45 degrees. Now that's going to be the number you're going to add or subtract over and over and over along the x-axis, okay? So write that down somewhere in your notes, 45. Then it says write down these partial ordered pairs. So I'm going to quickly sketch my ordered pairs. And if you're skipping this step by now and not really doing the ordered pairs, that's fine. The main thing I want to show you is get these values correct on the x-axis, okay? Now, if you'll look at the number from step 4, the horizontal shift, it was negative 45 degrees. So I'm going to put negative 45 degrees, okay? If you'll look at step 4, that's what you wrote down, all right? Now, if you'll look at step 5, you took the period, which is 180, and you divided it by 4, and you got 45. So that's what we're going to add or subtract over and over and over. So negative 45 plus 45 would be 0, plus 45 would be 45. And then subtract 45, we get a negative 90. Subtract 45, we get a negative 135. So there's some critical values to kind of help you get going with getting your points plotted. And then it says in step 6, substitute in 2 values in order to get out 2 y values. So I'm going to use negative 45 and 0. That's just me. And so negative 45. With my grapher, I would type in 3 sine, and then 2 times negative 45. And be sure and use the negative button, not the minus button. Negative 45 plus 90, and then close your parentheses. If you did all of that correctly, you will get out 0. So in other words, when you put in negative 45, you got out a 0. Okay? So I'm going to clear off some space here, give myself some room, and put a 0 here. Now you want to put 0 in for x. So I would type in 3, then hit sine, and then hit 2 times 0 plus 90. Okay. Now, I did just realize one thing, and guys, it's really difficult. Do you understand? I'm not defending myself. You understand when you're making a video and you get down to the end, there is no way, like when you're typing a term paper and you make a mistake in Microsoft Word, you hit backspace and fix the mistake. On a video, you cannot fix mistakes. You have to start the whole hour over. I just can't afford to do that. I'd like to show you one thing. I'm going to go back a page. Good. So that's not happening again. Okay. There's one thing I did. I didn't mess up at all in the teaching. Everything is so awesome. But a second ago, when I told you you got a 0 right here, That's not correct. Let me show you why. Let's go back to that. Let's go ahead and put negative 45 in again. So 3 sine, and then 2 times negative 45. We did all that. Plus 90, close the parentheses. And then what's right here? Plus 1. I forgot to put plus 1. I'm so sorry. I forgot to put plus 1. So really, instead of getting a 0 out right here, you would get a 1 out, because 0 plus 1 is 1. Now, if you were sitting in my class at Tennessee Temple or Berean, I would have said, hey, guys, go back and fix this in your notes. In a video, it's really difficult to do. So anyways, there we go. This is going to be a 1, not a 0. So now, with that in mind, now let's go ahead and put 0 degrees in. So it would be 3 sine, then parentheses, and then 2 times 0 plus 90 degrees, close your parentheses, and then hit plus 1. So that's exactly what your calculator should look like, okay? I think when you hit times, a little asterisk pops up on a graph, but nonetheless, this is exactly what you should have, all right? Now, if you type this in correctly into your calculator, you will get out 4. If you type this in correctly to your calculator, you will get out 4. So when you put in 0, you get out a 4, all right? So, a little messy, sorry, but I think we got this. So here's my critical values on my x-axis. Do you see them? I've got a 0 right here, so I'm going to put a 0, and I've got 45, so I'm going to put 45. We're adding 45. Even though I don't have a 90 up here, and my ordered pair is a positive 9, I'm going to go ahead and put a positive 90, and then a 135, and then a 180. I'm just adding 45 like I'm supposed to. I'm going to subtract 45, so negative 45, negative 90. I know we've never gone back and filled in those other ordered pairs, and I apologize. I just don't really feel like it's necessary. I'm just trying to give you a picture of what we're doing. I wanted you to see these x values, okay, that we're putting on the x-axis here. Okay, one ordered pair is negative 45, 1. So negative 45, 1. There we go. The other ordered pair is 0, 4. So way up here. So I know if I'm here for this critical value, here for this critical value, next critical value would be here. Next critical value would be down here. Next one would be in the middle. Next one would be up high. Now let's continue our pattern. Here we're up high. We're in the middle. Now we're down low. Then we're in the middle. And now we're up high. I'm not trying to win the artistic award of the year. I'm going to sketch these very quickly. You understand they're not going to be that good. And when you go to check your answers in the back of the book tomorrow when you do your homework, understand their answers in the back of the book will be in radians, so you'll have to kind of look at their answer and convert it over to degrees, okay? And that will help you. And also you can just follow my video tomorrow I'm going to do for you in your homework. Now, real quick here. Can you handle this, guys? Real quick. It'll take literally probably about 1 to 2 minutes. I want you to grab a grapher if you have a grapher, okay? Now, first of all, do these steps exactly what I say, please, okay? First of all, go to your mode and make sure you're in degrees. You should be all right, but make sure you're in degrees. Now, next, I probably should pull up that picture I have of, I hate to do that though. I'll just kind of describe where we're at. Next, what I want you to do is I want you to push the window button. Now, the window is the very top of your buttons, second one from the left. It's a real small blue button. Push window, okay? Now, do you see where it says X minimum, X min? Well, look at your x-axis, guys. Do you see it? Your lowest X value is negative 180. So go ahead and type in negative 180. Got it? Now, next is X maximum. Well, look to your right on your x-axis. The highest is 180, so go ahead and type in 180. Next, the scale, the X scale. Well, you don't want the X scale to be 1. Min, what were you adding and subtracting over and over? Weren't you adding and subtracting 45 over and over? So you want your scale to be 45, so type in 45. Next, you should see Y minimum. Now that's your Y axis here, your Y minimum. Well, how low did we go on the Y axis? Negative 2? Negative 2? Sure. So put a negative 2 for your Y minimum. And now what about your Y maximum? We went up how high? 1, 2, 3, 4, all the way up to 4. So your Y maximum should be 4. And now the scale, we were just in ones. We went up 1, 2, 3, 4. We went down 1, 2. So your scale is just 1. So your Y scale is 1. Now, the next button I want you to hit is Y equals, your top left little blue button. Top left little blue button says Y equals. Hit Y equals. And if you have any equations in, clear them out. Please clear them out, okay? And I want you to type into Y equals. I want you to hit 3 sine. and your parentheses pops up. I want you to hit 2x. And they say, Mr. Earhart, where's the X button? Well, listen to me, please, very carefully, okay? The second column from the left. Columns go up and down. Look at your second column to the left. The top button should say mode, M-O-D-E. Second column from the left, top button should be mode. The button right below that should say X, T, theta, and N. Do you see that? Push that button and up will pop an X on your screen. Okay? Then hit plus 90 and then close your parentheses and then hit plus 1. And then hit graph. Now, it might not work if there's something different on your calculator. If that's the case, come here Monday and I'll show you. But you should get this graph on your screen. And it's really, really cool. And that will help you, hopefully, find mistakes on a test or a quiz if you're making any. Okay, let me get rid of these bubbles here. There we go. All right, I hope you guys have a great day. I told you it'd be a long video, but hey, you've survived. No homework. No homework. Now, if you like to get a jump on things, if you're a type A and you like to get things done, fine. Here's your homework that's going to be on the website tomorrow. So here's what we're doing Wednesday in class. You're doing page 523, 1 through 31 odd. Yes, it's a lot of those. Will take about an hour. And then 41 through 44 all. So 1 through 31 odd, and then 41 through 44 all. Okay? And actually, I'm having second thoughts on this. I think this could be mega long. So hold on one second, please. 30 minus 15, about 2, so yeah, I'm talking to myself. Okay, all right, let's do this. I'm going to change this right now. I want this to be 3 through 31, every other odd. I just don't think you need 16 of these. That's really a killer. So we're going to do 3 through 31, every other odd, and then 41 through 44 all. Now, these will be new. You've never done those. We'll see how you do on those. You don't have to do this today. This is what we're going to do tomorrow on Wednesday. And here's the video you'll look up on Wednesday. It'll be pre-cal September 25th, which is Wednesday's date, homework. And that's all you do. You just watch a homework video and do the homework with me, okay? And that's basically it. So go ahead and change this assignment. This will be up tomorrow too, but in case you want to get a head start, 3 through 31, every other odd, 41 through 44 all. And there it is, and this is what you'll do tomorrow for a video. Call 706-965-2675, or email if you have any questions. Hope you guys have a great day.